Hi, my name is Nathanael. I'm a student here at Imperial College London studying aeronautical engineering. I'd love to tell you about my work on record-breaking rockets and how it all started with my school's STEM clubs. So let's start way back when I was in primary and secondary school, just like you might be. I took part in as many STEM clubs as possible, from Crest Award and the first LEGO League to maths challenges and Formula 1 in schools. Take Formula 1 in schools. It's the world's biggest STEM competition. Students like you design, build, and then race small cars powered by compressed gas. You also produce portfolios, presentations, and pit displays to present to judges at regional, then national, and then world finals for the most elite teams. With a lot of hard work, my team made it to the world finals in 2017. We travelled thousands of miles to Malaysia, where we competed with some of the brightest young engineers. And I cannot encourage you enough to take part with your school. Why? Well, first of all, it's so fun, and it brings you to places like this, studying after you've finished your GCSEs. But as well as that, you learn so many skills, whether it's engineering and technology, or more importantly, the soft skills you pick up along the way. Teamwork, communication, problem solving. Companies are looking for these in their future employees. So having taken part in STEM clubs at school, I was sure I wanted to study aerospace engineering, which, if you didn't know, is all about things that fly. So small aircraft, big jets, rockets and satellites are all designed and made by aerospace engineers. I then took part in a research project looking at a really cool part of satellite technology called ion propulsion. Imagine balloon-glowing rocket engines powered by plasma, which is being pushed out at more than 30 kilometers per second. And here at uni, I get to work with and learn from the academics and researchers who are working at the cutting edge of this technology. And this is their amazing laboratory. They have a beautiful vacuum chamber that they use for testing. And over here, they have a wonderful re-entry vehicle. This prototype is designed to be used on Mars for a satellite that's coming into land, whether it's a rover that's exploring or humans populating Mars. Now I'm at university. Even though I'm not in primary or secondary school anymore, I'm still taking part in STEM clubs. I'm the lead aerodynamics and simulations engineer for Imperial College London Rocketry's altitude record team. That means I work with hundreds of engineers to design, test, and build rockets. My team builds rockets that aim to break altitude records. So we want to fly as high as possible using aerodynamics, simulations, and the latest engineering technology to get us there. This is Apex, one of our small but mighty rockets. And in just over 3 weeks' time, we will be launching this from an RAF base in an attempt to set a new record. Apex is made from carbon fibre and fiberglass with aluminium fins and a custom-shaped 3D printed nose cone. Our team developed this using the skills that we've learnt at university, as well as loads of skills that lots of us picked up at our school's STEM clubs. Apex is the third rocket that our team have made. We've had 2 successful launches already to test systems that we're using on this very rocket. Let's take a look at a video of one of them.
Going in 3, 2, 1.
My job, along with a few other engineers, was to simulate Apex before we built it, so that we could understand what changes we needed to make it fly as high as possible. Here's some of the animations that we produced, and we also used the raw data that it gives us to understand how the rocket behaved before we even made it. I started using CFD in the Formula 1 in schools competition, but more useful than CFD has been the soft skills that I learned through my STEM clubs. Take this rocket. This was designed and built by a team of more than 20 students, and we were in constant communication. For example, if the structures team wanted to make the fins heavier or stronger, they needed to communicate that to my aerodynamics team so it wouldn't muck up any simulations. And there were things like that happening all the time. We were in constant communication, which is why teamwork and communication that you can learn through a STEM club are so important. And companies are always on the lookout for skills like these. I can prove this with an example. So I'm starting an internship this summer, working for a company, and I'll be paid to simulate things just like this, using the skills that I learned in my school STEM clubs. So my school STEM clubs gave me the communication, teamwork, and problem-solving skills that I need to design record-breaking rockets, to work well in group projects, and to look forward to a great career in engineering. Imagine, where could a STEM club take you? Why not join one and find out?